Sure. All right, here we go.
Would you tip me?
I've seen Coach White.
No. All right, questions over the review.
That we did.
Because mine is different. Like it has some of the same problems.
It has all the same problems. You just have more.
Will you check one?
Why do you have more problems?
She got hers early, and I reduced the number of problems after I gave hers. Elias? I don't have another. Well, I guess I can print it off.
Oh, yes.
All right, you said 15?
Yep.
It's so hot in here.
I know.
15 is one of my favorite problems.
I just thought about I had jingles.
Anybody want to come up and work 15?
No.
Anybody want to come up and work 15 for us?
Oh, I did that one.
You need to finish your quiz.
Wait, I'm almost done, but I think I did it right.
Come up and do it. Come up and do it.
Okay. I probably didn't. Okay. So like,
She's confident.
you know, I saw the table, so I figured it's probably like, don't you do the Riemann sum? Okay, then I didn't do it right. Next.
Spot on.
What is the answer? Negative 2.5?
Negative what? Pay attention. All right, Abby's got us. Pay attention.
Okay. So, I put.
So then you just plug it in like you normally would. So when you plug in -1 for f of x, you're over here and you get -1.5 minus. Plug in -4. You get -7.5. And the answer is -2.2.
Question? It was super easy.
What a baller.
Comprehension.
If I integrate f prime, what do I get? I get
You know, I
f.
kind of thought about that.
And then I've got my two values I plug in. So I plug in -1. Here's f. Here's -1. My value is -1.5. I go minus, plug in the bottom. So f of -4, f -4.75, and I get -2.25.
What?
Super easy.
Is that, what rule is that?
FTC, fundamental theorem of calculus.
Is that B minus F minus A?
F of b minus f of a.
Swell.
What else? Good job, Adam. Yes.
18.
18. Anybody feel good about 18? Did you print one off?
No, but I'm going. I'm looking at items.
Okay. All right, anybody know what's going on 18? Maddie?
I mean, I know what's going on.
All right, tell me what's going on.
You have to find the area under the graph so that it equals 2, because whenever you divide by 2, it'll equal 1.
When you divide by 2?
Yeah, because up here
Okay.
you have a 1/2.
All right. So what I did was I understood that this was 1/2, and then I wanted to get this by itself. So if this is 1/2, to get rid of it, I multiply both sides by 2. Okay, and then we should know, Zach, what two things does this represent?
The area under the curve of the line or whatever?
Area under the curve, and what's the second thing it represents?
I don't know.
Elias, what's the second thing it represents?
Change the function
Changing the function above. Thank you. Okay, and obviously if we have a graph, then that means I'm interested in the area. So what this says is I need an area that's equal to 2. So I come over here and I look at all my graphs and find the one that has an area of 2. This one has an area of 2, so that's my answer.
What? On mine? How did that area two?
Just go with
Because I've got a triangle that has an area of 1, and then another triangle that has an area of 1. And it adds up to 2.
So then how would you find the area of the other one?
Well, this is that's going to be 2 by 2, so that's 4. This one you can do a trapezoid, or you can break it up and do a triangle and a rectangle. So this is 2 down here. That's a 2 by 2, so that's going to be 2 as well. So that total thing is 4. These, since they're curved, you're not going to be able to find them. So more than likely, you could have eliminated those right off the bat because you can't find them. Zach? 19. All right, can anybody talk to me about 19?
Do you do the, what's it called, second FTC?
You do the second FTC.
So you change it to sine x squared? Yeah.
So we understand that g prime of x is equal to sine of x squared.
And what, how, I tried to plug it in my graph, to graph it, I tried to plug it in as the integrated, but I don't know.
Why would you integrate?
I don't know. I didn't know how to do it. I didn't know how to tell.
Well, how do I determine if something is increasing or decreasing?
By graph.
A graph of what? The derivative. What do I have right there?
The derivative.
The derivative.
I plugged that in to the graph and it didn't look like some weird thing.
You should pull it in. Plug it in. Plug this into your function. Make sure you limit your window. And if I'm decreasing, then I'm interested in when that graph is what? Negative. So then I find out where it's negative. Ends up being negative there. Isn't that what we found out? Okay. So graph this and change the window. Can somebody talk me through changing the window on your calculator? Menu. That's finding a 0. Menu 4, which is window settings, and then it's 1. So it's menu 4 1. You change it from -1 to 3. That'll give you your window, and then just find out where it's negative. And all you got to do is really find out whether or not I have one of these 2 points. Once I find one point, then I don't need to waste my time finding the other point.
So when you plug it in, you wouldn't have to, you just put sine squared in, you wouldn't put.
All I do is put that in right there.
So I put the antiderivative symbol.
I want my derivative. My derivative tells me when I'm increasing or decreasing.
Wait, so like, you go on the graph, is that what you graph?
I need to graph this, and then I'm gonna change my window.
Menu 4.
Menu 4, and then change my window. Okay, and then in that window, I want to know when am I below the x-axis. So then all I have to do is find one of those zeros, and then one of those zeros is going to match and give me my window.
I'm not gonna remember that one.
What else?
But if you don't change it, will it still give you the right answer?
You can still get it. It just makes it easier if you know this is where I need to be looking.
Did you change your graph to like the x-axis?
Changes the x-axis, yes. Okay, that way I'm only because I only want to know when am I decreasing on this interval. So I'm just going to narrow that down. When am I decreasing? When am I below the x-axis?
You said it was C or D?
D. What else? Yes.
24.
24. Somebody tell me real quick so I'll know which ones not to do when I make the rest of the videos. Which ones have we done so far?
18 and 19.
18, 19,
24. 12.
24 is what we're getting ready to do.
Yeah.
And we did something else too.
15.
15? All right, 24. Alright, so g of x equals this. So if I want g of 1, I plug 1 in there. So this is from 3 to 1. So I like to mark my anchor, knowing that everything is based off of that spot. Good. So the first one is g of 1, so that means we're going from 3 to 1, which is right there. Since I'm going backwards, what do I have to do?
Negative.
Make it negative. Alright. So on this, I have that, and then I've got my quarter circle. So that is 2 by 2. So g of 1, I'm going to be negative. So that's going to be 4. And then I have a quarter circle, which is 1/4 pi r squared. My r in this case is 2. So 2 squared is 4. So we're looking at negative 4 minus pi for g of 1.
Why couldn't you just get your answer and then put negative out in front of it? So what do you have? Negative pi plus 4.
Make sure there's parentheses around the pi plus 4. If you don't have parentheses around it, it's wrong. All right, g of 7. So we want to go from 3 to 7. So 4, 5, 6, 7. So I already know what that piece is worth. How much is that worth?
Or 4 minus pi, or 4 plus pi.
It's 4 plus pi. Okay, it's 4 plus pi, and then I have this little triangle, which is 2 by 2. So 2 times 2 is 4. Half of that is 2. So that I'm ended up with 6 plus pi with that piece. And then g of 9. What is g of 9 the same thing as? G of what? G of 5. Why is it the same thing as g of 5, Brady?
Because the triangles cancel.
Yeah, these two triangles right here cancel out. So all I need to know is how much is this right here. And we know that's equal to pi plus 4 or 4 plus pi, either one. So there's that. Then we want an absolute maximum value of g on the interval. If I'm going to do an absolute max or an absolute min, what do I have to consider?
Where it crosses.
Where it touches the x-axis and my endpoints. So my endpoints in this case are g of negative 2. The other one is g of 9. And then I cross the x-axis at g of negative 1 and g of 7. So I know most of these. We know g of 9 is pi plus 4. I don't know g of negative 1. I don't know g of 2. I do know g of 7 is 6 plus pi. Alright, so g of negative 2. Well, let's find g of negative 1 first. G of negative 1. So all I need to know is what this triangle is right here. That's a 2 by 2 triangle. So 2 times 2 is 4. Divided by 2 is 2. And I already know till 1 was this. So I'm going to end up with
2 plus 4. Wait,
it's going to be negative. So a negative 2 and a negative 4 is going to give me a negative 6. Everybody with me on that?
wait, why is it negative?
Wait, what?
Because remember, you're going backwards.
Oh.
So anything above is going to be negative. So I already know this right here is negative 4 minus pi. We just figured out this was negative 2. So negative 4 minus pi plus a negative 2 gives me negative 6 minus pi.
So when you do absolute value, you do whatever they give you 2 or 3.
Absolute value. Where are you getting absolute value from?
Should be an absolute maximum.
Absolute maximum. All right. What are you saying?
So we're going from the number they give us to 3?
Yes.
Okay.
To get the values, you always start at whatever they give you. You got to start there. That's
So why
all.
does it still be negative even?
Because you're going backwards.
Like negative 1
3
to
to
3.
negative
Oh,
1.
okay, okay. I looked at negative 1 and 3, okay.
All right, so then I need negative 2. The only difference between negative 1 and negative 2 is this little triangle, and how much is that little triangle worth? It's 0.5. It would normally be negative, but since I'm going backwards, it's positive. So that means we're looking at negative 5.5 minus pi.
So why is that? What? Positive.
Because Remember, if you're going backwards, everything changes. You gotta stick a negative in front of it.
Yeah, I know. So that little triangle right there. Never mind.
It's normally a negative 1/2. Since you're
Yeah.
going backwards, it's a positive 1/2.
I got it. I was looking at the warming triangle.
Why
So-
are you doing -2?
Say it again.
Why are you doing -2?
Because it's an endpoint.
But it's not the end.
You're right.
Yeah,
Hey,
I was
turn
confused.
up.
Oh, yeah.
So that's gone. I didn't notice that.
I was-
Good catch. So we're looking for an absolute max. Our absolute max is 6 plus pi, and it occurs at x equals 7.
What the explanation would be because it has the highest value?
Nope. Remember on absolute extrema, your work is your justification. The only time you have to justify verbally is if when you're finding what type of max or min.
So I think
Relative.
you should take that justify part out then. 'Cause that-
No. It's gonna be on the AP test.
So if I write because it has the highest value, then I can count me off, are they?
I wouldn't do it. You should know what to do. You should know what to do when you see this problem.
No, I know. I mean, you find the answer.
I know. Then don't do something you know you're not supposed to do.
But
That's part of me training you. I'm training you how to respond to these questions.
Okay.
So if I tell you to do something, that's the way you need to do it. All right, identify any points of inflection. I feel like we're really good at finding points of inflection. Ivan, what's my point of inflection?
Would be 3.
3. Why is it 3, Ivan?
Because it changes from increase
All right, you said it.
to the derivative.
I don't like that. Be more specific.
F prime.
No.
F.
What does that say underneath the graph? It doesn't say. Well, what does this tell you? It tells you the graph of function f is over there. So this is f. So I want to say because f changes from increasing to decreasing. Now, if I'm going to talk about f, what do I have to establish somewhere?
G prime.
G prime equals f. Make sure you say that. Some of you on the quiz did not say that. Make sure you do that.
We did that.
That's good. All right, that was 24. Alini?
I put that on B. Is that okay?
Yeah, as long as it's somewhere in here, you only have to say it once. Doesn't matter where it is. Zach?
23.
Copy your boot out.
Chuck White.
Yeah, it's fine.
When you retire, Chuck White, are you mean actual cowboy?
You look like the Yee-Yees in my ag class next time.
Yeah,
The
sure.
Yee-Yees?
Yeah.
What does that mean?
You know what I'm talking about.
I know what you're talking about.
Yee-Yees. Like, they're not really country boys.
I'm not really a country
You're like
boy.
Jason out.
No, well, but you're not a Yee-Yee. Like, there's a difference. But I'm not going to get into details, especially with the camera. You know, I don't want people to...
I want to have.
All right, moving on.
But they all wear their boots like
What
that.
is a heat?
All right, Darrell. Darrell, 23. I want to find the average value of that. Set it up for
Would
me.
you?
I wasn't here for average value, but I believe once you do 1 over 2 minus A, so that'd be 1 over 2 minus 0. Which is 1/2.
Right.
And then you set up the integral, which would be, and then you find the integral of x squared.
All right, so I do that. What'd you guys end up with? Speak up.
2.889.
So 2.889.
So you don't integrate the y? Why does when you put it in? Like you're not like you integrate, but you don't change it to where it's like 1 over 3x.
No.
You put it in the calculator.
Okay, I see that, but how about you put it in after you?
Yeah, you plug it in just like
Then you plug it in just like that.
That's how you get that.
Don't do anything by hand if it says use your calculator.
Huh?
You don't do any derivative. You don't do any integral by hand if it says use the calculator.
Do you have to put 1 over...
If you
B
do 1/2,
minus 8, or
if you
can
do
I
1/2,
just, like-
1/2 is fine.
I didn't know if you wanted to see that step.
All right, Haley, what do we do with part B?
I have no idea.
Yeah, you do.
question, Coach. No idea.
Ready? What do we do on part B?
Set it, or put that equal to
Okay, because, raise your hand please, what does the MVT for integrals guarantee?
Your average y value.
Sorry, raise your hand.
Obviously, wrong.
Zach,
Average y value.
you gotta give me more than that.
Your-
Ready?
there's a y that will equal the average value.
Okay, there's a y value that exists on my interval that equals the average value. Very good, thank you. Okay, then from here, again, it says use your calculator. So what do I do to make it to where I can use my calculator? I subtract that. Then I graph that, and then I look for where it crosses the x-axis on my interval. So you want to change your window again. Change your window from 0 to 2. Figure out where it crosses the x-axis, and then find that 0.
But make sure we got this right. Change your window. How do you do that?
Menu
Menu.
4
4
1.
1. Write that down.
Menu 4 1.
You gonna put that on the smart board tomorrow? Or right there?
An accident.
Nope.
What?
Do you still have to click on both sides too?
Yep.
I need.
Oh.
Yeah, it'll let you use number 4. All right. So what did we end up with here? Somebody, Elite, what do we get?
1.280.
1.280. Remember, when you give me a decimal, how many decimals do you have to give me? 3. Don't forget that. Make me real mad if you don't give me 3. Because they will take
Real
off.
mad.
They will not give you credit unless you have 3 decimals, if it's a decimal.
Do you have to round it, or is it just 3?
You can truncate it or round it.
Whoa. If you chunk it, you have to do 4.
You guys know what?
don't you?
Nope.
I don't know.
I don't know what truncate means.
They will not look past the 3rd digit. They will look at that 3rd digit and they'll stop. Who knows the difference between truncating and rounding? Haley, what's the difference between truncating and rounding?
Okay, you just stop the program.
Yep. And rounding means obviously round. That's it.
So like.
So on that top, it was that. So truncating would be stopping there, and then rounding would be changing it to that.
So do they?
They take both.
Okay.
But again, they don't look past that digit right there. Okay? They will not look at what's back there. So if you put more digits, they're not going to look at it.
I don't even have to waste your time. Waste my time around.
You don't want to figure out.
Like it's hard.
You don't understand what's difficult for me.
All right, what else?
I'm just
What else?
number 12 on the quiz.
We got about 20 minutes left. You got one? No.
We did 26.
26.
I don't know, that was kind of interesting looking.
And we better get 26 right.
Good.
Zach, what type of problem is 26?
Flip there real quick. Up to the board. It's the second FTC.
It's the second FTC. What does the second FTC tell me to do, Zach?
The derivative and antiderivative cancel, so you just plug in your non-numerical value to where your variable is.
So I plug that in,
And you take the derivative. So
which gives me that, and then I take the derivative of what I'm plugging in, which is that. And since it was on the bottom,
that's negative.
I need a negative.
That's what I was going to ask. It's like the whole thing negative.
Yep. So that's what we end up with. Do not miss the second FTC problem. You'll have a negative and a negative.
Oh, you said you just put them around.
Come on, where did you get that buckle at? My brother.
Does
Your
the
brother
negative
cowboy?
not go
He's
to,
more
like,
of a cowboy than I am.
Do we have to change it around like that, or can we leave it like the first?
I mean, technically, this is okay.
Does the
But
negative
if it's
not go
if
to,
it's a multiple choice problem, that's not going to be the answer.
Does
Yes.
the negative not go to like all of it and then like?
Nope. It would only go to all of it if you got it separated by addition or subtraction. Then it needs to be distributed. But if everything's being multiplied, it does not get distributed. Yes.
Also, on function like these, when it says to like, what does it say? Instruction. It says to evaluate the indefinite or definite interval. They don't give you values on like your mean a
Limits.
values.
If they don't give you limits,
Yeah. Do you just integrate it and then
you
do
put
it
plus C.
plus it, I guess.
That's it. Don't forget your plus C.
I'll let you. I'll plus C.
All right, so 3 is going to stay. If I integrate secant tangent, I get secant. And we're going from negative pi over 3 to pi over 3. And remember, since this is one term, what do I want you to do with this number? I didn't hear that.
I'm sorry, I was younger. Take it that side.
Take it to the outside. So all I need is secant pi over 3 minus secant negative pi over 3. And that gives me 3 times 0, which is 3. Or 0. 3 times 0 is 3. Some new math. Some new math. Because this gives me 2, and this gives me 2. 2 minus 2 gives me 0.
Are we gonna get those on the test, or do we have to have those memorized?
You gotta have memorized.
Oh. Okay.
What, secant of pi over 3? You know that?
You gotta know that.
Secant tangent.
No, I mean like the secant tangent, like
You
the.
gotta know that too.
How are those secant
You have to know all of it.
You gotta know it. You should know what cosine pi over 3 is. And you should know that secant is just a reciprocal of cosine. End of story.
I really need to start making some of those things.
Yes, I'll follow.
Alright, what else?
11.
11?
I don't know how you do that one. I don't think I was there for this.
I'll give you a whole thing.
There's nothing fancy about it.
Now, Roy, I got it.
Alright, who can talk to me about 11?
It's a
Oh.
number.
Zach?
Is this the one where, wait, shoot. You set it equal to, or you integrate it and you set it equal to the basic over 3?
Alright, so if I integrate x squared, I get 1/3 x cubed from 2 to k.
And you plug it in.
Set that equal to 56 over 3.
What do you get? 1/3?
I've got a 1/3 here, so it's going to stay out. I've got k cubed minus 2 cubed, which is 8. I get rid of that 1/3 by multiplying both sides by 3. I add 8. Take the cube root. So k has to be 4.
Okay, that's really easy.
Because, like, you probably have another copy of the review,
Well, I mean, you can print your own out.
but this has stuff on it. Oh! Never mind. Never mind.
Oh, I don't know if I got 13 right.
13.
Yeah. I get a little confused on those sometimes.
Alright, 13. Which one's the answer to 13?
I always do. B.
Oh,
Is it B?
Is it a constant?
Okay, good. So I did it right.
You're trying to find the function of the, so when you integrate velocity, usually the function of the.
Alright, so here's a question. What's the other possible answer they could have given you instead of this one?
It's like,
It could have
it'd
been
be
like.
S of 8 minus S of 0 over 8.
Very good, Zach. So they would have given you one of those two. They will never give you both, but these are the two possible answers you could expect to see on that problem.
Because why? Can you try to put that?
Did you choose? Oh my gosh.
What?
They won't
They won't give you both. They're going to give you one or the other.
It's just like, make sure you're posting this video, right?
I'm posting.
I'm gonna record
Ooh,
that.
16.
Okay, good job, Zach. I live for moments like these. Yeah, good job. I put you a B. We're going for a B right now.
Great job.
Yeah.
Good job, Zach.
Alright, what did we ask for?
16.
All right, 16, the flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown above, even though it's shown below and to the right. Of the following, which best approximates the total number of barrels of oil that passes through the pipeline that day? So notice we want to end up with barrels of oil. Right now, we are barrels per hour. So how do I go from barrels per hour to barrels?
Multiply by hour.
Multiply, which means integrate. Okay, and if I'm looking at a graph, that means I want area under the curve. Notice that each one of these rectangles is 600. This looks like it is 2 of them split, so I'm calling that 600 as well. There's 5 600, which gives me 3,000.
I was trying to take the area, but I was kind of confused on that.
Yeah, I understood the area. Exactly. I was trying to do exact.
Well, it does say approximately.
It does.
Okay, Abigail.
All right, what else?
That one. That sharp piece.
How you doing, Abby?
I'm done.
Okay. Other questions?
Was there not a number 8
Did I miss 8?
and a 10? There
And
is?
there's an 8.
Oh, there's the 10. There's. I was looking at the sides and I was like, what? I'm confused. My bad.
What else?
I think. I think that's everything else.
Oh.
22. Yeah, I was just saying.
22. Yeah, I'm glad you brought that up. 22 says let f be the function given by f of x equals 9 to the x. If 4 subintervals of equal length are used, what is the value of a right Riemann sum approximation of that integral? So we want a right Riemann sum approximation. Usually when you do a Riemann sum, what else do they give you? They give you a table. So that's what we want to do. We want to make a table. So we want x and we want f of x. And if I'm starting at 0, I definitely know the first one's 0. Okay, what do I want to finish up with? 2, and how many intervals do I want? 4. So if I take 2 and divide it by 4, that means my distance is going to be 1/2. So now I just need to get the y values that goes with each one of those. I've got my table, then it should be super easy to get my Riemann sum. All right, so where do I plug 0? Into the function. So 9 to the 0 power is 1. Plug in 1/2. 9 to the 1/2 power is 3. Plug in 1. 9 to the first, obviously 9. 3 halves, 27.
This interruption time. A
And
reminder, since we were out Tuesday, if you had or were scheduled ASD, you need to make sure that you attend this afternoon. Reminder, if you missed ASD because of school being out on Tuesday, you need to attend tonight or today. Thank you.
When we get 60? There it is. So if they ask you to do a Riemann sum and you don't have a table, make your own table.
How do we get that increase by 1 hour?
It's at 4 subintervals of equal length. So I take whatever my distance is and then divide by the number of intervals. So 2 divided by 4 gives me 1/2, so that means each one's going to be 1/2 apart. Anything else?